We just finished lab 8.2. This is about corrosion, or in particular rusting. Here's a sample of the after effects inside of a test tube, and we took one of these out of the test tube so we could look at it up close. So I'm going to set this test tube out of the way. So before the reaction begins, we started out with steel wool. We rinsed it with some vinegar to get the protective oils off of it. The manufacturers put a coating on there to keep it from rusting in the package. And then we know the equation: iron plus oxygen from the air yields iron oxide, which is rust. But we started out with this. We get oxygen from the atmosphere, and we end up with this product. We aren't able to get the mass. We aren't able to get the mass ahead of time and then afterwards very well, because this, like I said, this has a protective coating on it, and when we rinse it with the vinegar, all of a sudden we would be measuring the mass of the vinegar as well. But I will remind you that iron plus oxygen, when it's combined, is going to have a greater mass per molecule than just iron. So if we just say started out with 5 grams over here, if we had the same amount on this side, the rust would have more mass because the oxygen is attached and has become part of that molecule. So the way this lab was set up, and this was done about 5 minutes ago, so the rusting has largely completed, but we took the freshly rinsed steel wool, put it into a test tube, kind of packed it up in there with a pencil, leaving some airspace in between the filaments. We took an empty test tube and put it in the container of water right next to it. Now, this part is going to be difficult to see, so let's get the pointer back out here. So we have the surface of the water touching the outside edge of the test tube. If you look down in this test tube, you can tell that the air goes all the way down to the bottom. So I'm going to move the test tube on the left. You should be able to tell that the bubble, the air, is all the way down to the bottom edge of the test tube. Then we may be able to get a bubble to come out. Well, you can see the bubble at the very bottom edge, so that the test tube is still full of atmospheric air. The test tube on the right with the iron that has been rusting, using the oxygen out of the test tube. And remember, the atmosphere is not pure oxygen. It's about 80% nitrogen. But if you look at the bottom edge of this test tube as I pull this upward, you should be able to see that the water is about 1 centimeter up into the test tube. So the water has moved into the test tube because the air that was in here with the iron has gotten smaller. The oxygen that would have taken up that extra centimeter or so of test tube has combined with the iron to form rust. And so the oxygen is no longer out as a diatomic molecule, and it's attached to the iron. So the oxygen the gas is no longer in the tube. It's part of this molecule. And because it's no longer gas, let's see if we can get a better shot. Because it's no longer gas, the space inside the test tube gets filled with the water from below. I'm going to go ahead as a final parting view. I'm going to pull this test tube out, and we should be able to see the volume of the oxygen that was used to spill back into the bowl. Okay, so about 1 centimeter's worth in this particular test tube. All right, so iron plus oxygen from the atmosphere yields iron oxide, which is rust.